I had to pull the power switch out right quick so I could take it down to Radio Shack and get a 1 meg pot that's comparably the same size. That way I could stick it in here, and then I'll move the actual power switch over to where that speaker switch is. And you could hate me because I have a brand new Radio Shack right down the block from my house, and it's like 2018. I just got back from Radio Shack, and I used the switch, which is somewhere in my pocket, I think. It's somewhere, it's not important. But I use that switch to size up this potentiometer, this 1 meg linear. They all come with this size shaft, so it could be cut down. I'm going to put that to the Dremel after I measure it against this shaft for the volume, so I have the right size. That's just fine. And then I got 2 of these jacks. It came in a pack of 2, and it also has, as you can see, the little ground post when it's disconnected to short the input to ground, which is really cool too. So it'll be nice and quiet when there's no guitar plugged into the amplifier, which is what we're going for. Calipers say we're looking at 1 centimeter. So we're going to go with that for the other one as well. We're going to take this shaft and mark it right there, and then we're going to cut it on the Dremel. I saved everybody the dremeling and filing, which was very uninteresting, but here's what I came up with, and then I sort of chamfer down the edges there so the knob would go on nicely, but this is it. So we'll try it out. I got to do this in order though. I had to pull out the power switch obviously for the potentiometer, which means now that I have to pull out the connections of the speaker switch to accommodate the new power switch. This one's really easy though, because this is just a connection to ground off the coil. So we're going to clip this out, ground that coil permanently, because we're not going to go with a speaker switch any longer. And then we'll rewire the new power to the speaker switch. Then we'll worry about potentiometer. In a nutshell, this black wire right here coming off the audio transformer, this coil, this black wire grounded is what turns on the speaker. So I'm going to clip this off of there, and I'm going to find a suitable ground for it, and that'll be the end of it. The other side of that switch was the connection to the main star ground here. I simply clipped that off. The switch is now free of anything. It's just an open switch now, ready for whatever we want to connect to, and that will be main power. But that brings us to another discussion, because power was a 2-part switch in the old system. We're going to short one connection together and make it a 1-part switch. It's just going to be AC now. So the second half of the power switch connects the green wire coming off of this audio transformer to the rectifier right here, the diode. And so I'm going to bring these together like that, and that should satisfy switch 1B, that requirement. While the soldering iron's heating up, I removed one of these lugs from the old coil connection and brought it up here to the speaker. I don't know if this is a very good ground. We're going to find out, but I'm going to use it to hook this black cable to. That'll keep the speaker in the permanent on position that I discussed earlier. So now I have the green switch 2 wire done directly to the diode, and the speaker permanently on wire done. I now have one more power wire or power circuit to take care of, and that's going to be the AC. I've been thinking maybe it would be prudent, given the available space to work here, I might put the on-off switch in the lower position, only because I have a better view and a little more clearance for the 120 volts. I'm also going to put some shrink wrap around those connections as well for good measure. So now I've got the second half of the AC installed to the switch down here. This is the old noise switch. This completes the power relocation and leaves this hole available now for the tone knob, which will be installed next. I think we're going to stop though at this point, and we're going to put this thing back up on the Variac and make sure everything's working fine. Done an awful lot of modifications here with regard to switches and power. Again, we're looking good. I had a little glitch here because the 0.0047 had shorted against the coupling capacitor. It caused me a little grief, but I found it. But here we go. We could see the magic eye tube. It's hard to see in the camera unless I cover it up a bit, but everything's working fine. And I know this is all going to require adjustment. The point is, you know, the power switch is working. Now you can see it's off and it's back on. So everything up till now is good. We could move on. I've got the new potentiometer installed, and when I put the knob on, tighten it down, you won't even notice that it didn't come stock like that. It's just going to come out perfect. And here's the travel of the new knob with the arrow pointed that way. Move it over a little. And there's the tone knob. So I've started rewiring the temporary tone connection I made. I've relocated that 500 picofarad capacitor coming off of this tone pot. This green wire is coming off of the pin 2 on the tube. So it's going from pin 2 to this 500 picofarad capacitor directly into the tone pot. And I wanted to show you that before I put this piece of heat shrink over it to stabilize everything. Now I've relocated that 0.0047 microfarad capacitor to the other side of the pot right here. So I've swung it over and the other side of that goes to ground. So now we have 2 connections done. Finally, the third wire I swung over from the volume pot. I didn't measure it for size because if you'll remember, the volume pot has to be reversed as backwards, so I didn't pay a whole lot of attention to it. I just wanted to get that connection in. So we have what appears to be a finished tone control circuit. The old temporary 50-50 has been ripped out. This seems like a good point to test them. I don't know what kind of tone difference we'll hear with a signal generator because we only get 1 frequency, but we'll see what we can do. We have to inject something else into it. We'll find out. See if it even works. Okay, so we do have something. We definitely hear something changing with the tone. It's good enough for me as far as function goes. Thinking what I could put into this as an input. Maybe we could get something else to input into this. Okay, let's try out the tone knob with this commercial.
Make the season more special. So join Coca-Cola and Clearwater Marine Aquarium for Winter's Wonderland through December 24th. Celebrate the season with your holiday hero.
And there's
Coca-Cola.
bass.
Taste the feeling.
Everybody deserves a Swiss timepiece for Christmas, and International Diamond Center is making it
trouble
with incredible offers on all pre-owned Rolex timepieces.
Definitely works really nicely. Real nice treble and bass on that tone knob. We're going to call that a success. Just for fun, something different, we're going to drop this phone jack in here now, stage that, and then we're going to see about wiring it so we don't have to use this little pigtail resistor that we've been using thus far. And this is all set up nicely. It just needs to be redone so that it's mounted onto this, and then we'll be good. So I got the jack installed. It looks like it belongs here, like it came with it. That came out really nice. I'll probably get that thing centered, but really good clearance. And like I said, again, it's one of those jacks where when you insert it, it breaks the ground connection, so you don't have any noise when it's not in there. I have one of my Heathkit test cables to plug in and test it, and the clearance is good against the power transformer, so this is good. I'm going to wire it up now. So I've got the star ground wire coming into the jack here, and then I have that secondary yellow cable here, which is the shorting cable when the plug is disconnected. Now all I need is the final signal cable, and that is basically this connection coming off these 2 resistors, which I'm going to redo to bring those resistors over to the jack where there's actually room. And there we go. All the connections on the jack are done. All the resistors are in position. And most importantly, what it did was it removed all of the temporary stuff that had to be put in on this side, making room once more for the magic eye tube to be seated here. There is no extra parts save for the components for the cathode bias capacitor and resistor here, and a capacitor here, which has more than enough space. Everything's going to slide in just fine. So with everything that's been done so far, the fitment should be okay. I predict there'll obviously be some challenges as we build onto this, but right now we're doing good. I'd like to get the magic eye tube seated in the chassis for this test. It was just catching on something, but I see that the space is more than enough. There's no problem at all. We're going to run it like this. We're going to stand it up and actually give it a test drive with the new jack now as the test point. So I got it warming up right now. I shut off the front camera so we could see the magic eye tube a little better. First test is without this, and I'm going to turn up the volume now, and it should be dead quiet because it should be shorted to ground. So, and it is in fact quiet. We can see full tilt. That's working just fine. Now let's take the this is my test cable. I have it plugged into the shortwave radio again, so I'm going to plug that in, and we're going to turn up the volume.
800-471-6845 or go to selectquote.com. Since 1985, we shop, you save.
Working good.
Get full details on the example policy at selectquote.com/commercials, or price could vary depending on your health, issuing company. Available in all states. It's the Subaru Share the Love event here at Peacock's 2017 Crosstrek 2.0i Premium, just $198.
I apologize for the volume.
Subaru or peacocksubaru.com. Go to peacocksubaru.com for full details.
You know, before you know it, the
Yeah, very good.
holidays will be
Okay,
here.
so
Friends
we're able
and
to move
family
on. You know, I always work just a little bit ahead of the video to see what I'm going to do next. You know, seems reasonable. And I had hooked an oscilloscope up to here, and I started looking at the waveforms coming off the first stage of the 12AX7 up here before this coupling capacitor, and then coming out of the volume knob into the second stage before the 500 picofarad capacitor. And what I found was that the sine wave looked really nice here. It looked like crap over here. And I was just starting to get into the troubleshooting regiment when I said, I know the volume knob is on backwards. We've already determined I just sort of wired this on backwards. So I was just going to start taking it off and then using some banana clips to isolate the fault where this sine wave that went from pencil thin to still look like no distortion, but was like really fat, like it was drawn with a marker on the oscilloscope. So what I'm going to try and do is I'm going to flip these around, and I'm going to straighten this out because it's already a known fault. The signal coming off of 6, right? Now, mind you, I'm going to show the signal coming off of 6, and then I will show that signal coming into 2, right? So the only thing that is going through is this coupling capacitor, and I'm actually going to measure it from the other side of the coupling capacitor. So I'm measuring it right here, and then measuring it again at 2, and seeing how the quality is diminished. And then we're going to talk about what we're going to do to isolate what the cause is. You can already see that I have a disconnect 1 labeled over here at this 500 picofarad, but let's look at it first. We can see the signal coming here. This is off of pin 6. And you could actually see the sag. Watch this. See that? That's awesome. But we can see how clean it is. It's very defined. It's looking real nice. So this is the first stage, and I'm reading it off of the other side of that coupling capacitor. It's going right into the volume knob. So I'm going to pick it up off of the other side of that volume knob. I'm on the other side of that volume knob now. Obviously I need to, and I realize that I got to make it bigger for you to see, but we can see that the definition of the sine wave has changed substantially. And it could be because the pot is not as good. It's not a good quality. Unfortunately, I have to make the audio loud to see this, you know. See, the sine wave definition is definitely not as tight as it was. Maybe I could get a before and after picture on there. Subjectively, though, it could be argued that when you look at the full power output, and I'm going to lower the volume in the video so I don't blast the camera out the door. But if I go really small and amplify, it doesn't look too bad. And this comes into the next topic of discussion. Aside from the fact that there are artifacts with the rectifier, which is a separate discussion that's going to come up. The voltages for this 12AX7 are 61 and 77 respectively, with a bias of 0.5 and 0.6. It can't expect any headroom from this preamp at all before it starts breaking up in any sort of fashion, which we want a little bit of distortion here, but it's way too low. And if I go and I look at this diagram right here, right, I'm running off of this 114 volt drop after this 10K. I have the option, should I so choose, to run off this 138, which catches it right off of this rectifier right here. That 138 will give me at least or close to 100 volts on these tubes based on these values in and around. I'll measure them and let you know. But I'm thinking if I could get more plate voltage out of these, I could stabilize these 12AX7s, and I think that's what I want to do first before anything else. So I moved that 114 volt connection for the beam power tube down here to the capacitor, so that hasn't changed. This is the voltage dropping resistor, which brings that 130 something volts, 140 volts down to 114. That one's safe. Then I relocated this Y right here is the voltage dropping resistor for the 12AX7. I've moved that bridge over to here before that, bringing that to 140. What I am losing, however, is the second filter, right? So we're gonna get noisier DC for this test. I'm good with that for the test, so I could always, if need be, clamp another 50, 60, 70 microfarad capacitor to this for testing purposes and deal with that later. So let's begin. We'll do some voltage measurements. As expected, you can hear it sounds like crap, especially for a single selenium rectifier. I'm just gonna drop an 80 on this filter here temporarily and call it a day. We'll continue testing and take some voltage measurements. We can see there's with the 80, and I could drop the capacitor on. I could get it down to that, but with that single diode rectifier, there's just no way. There's just too much sawtooth not having that really big voltage dropping resistor in between the two to take that hum out of there. So it begs the question, do I stop now and add that bridge rectifier in to try and straighten this out? And I think the answer is yes. So first thing we'll do is we're going to pull back this red secondary winding. This is how we're going to convert this thing to a bridge rectifier. So just snip this. This is a ground connection right here. You'll see it in a second. And this is that red cable. And this red cable will meet this existing red cable right here. And we can see that it's particularly short. I'm going to go and cut this one too off of this diode, and I'm going to pull it back. And the reason why I'm going to pull it back is because I need to get in there with a drill, because I need to make the holes just a bit bigger to be able to work. I'm going to have to get, 4 wires through there. And I don't want to damage anything. So these are going to be my AC inputs for the rectifier. And that's all we're going to worry about right now, but I want to ream this out right here. First order of business is done. The hole is drilled bigger. We can now fit all the wires through. So I now have half the rectifier in. We could see that the 2 leads coming off the winding here are going right up into here. I've soldered everything together and dressed it. I now have the positive and negative side that I need to wire in now. I end up using this old one as a mounting post where I would generally put the voltage dropping resistor. And as I install this, I'm going to discuss that. You would expect that I would put a resistor here between the positive of this rectifier and these cables here where they merge. You can't see the other cables right back here going down to the filter caps, right? Because we expect with the different forward voltage drop of this, the DC voltages are now going to be higher, maybe up to 10 volts higher. But the fact is, we already know I'm trying to get more voltage out of this anyway. They are too low. Now, if I get another 10 volts out of this, that 114 volts going to the beam power tube shouldn't be too bad. And if it is a little too high, I can always put in a higher resistor. The main focus is the 12AX7s. And what we're going to be looking at now as we fire this back up is that DC, and we're going to see if it cleaned up now with this bridge rectifier. This is going to be a major improvement over this old clunker right here. So we'll see what we get. Underestimating the voltage drop of the old rectifier versus the new one, and the cleaning up of the DC and the benefits from that, I was amazed to see how much the voltage had actually climbed throughout the circuit. It was substantial. So what I had done after seeing that was I said, wait, let's dial this back a notch. What happens if I bring this circuit back to the original configuration and take some measurements? And I'll tell you what I got. I got, as I predicted, for the beam power tube, 124 was a 10 volt increase after going through all those resistors and what have you within a safe range. Absolutely no problem there. The good news of this story is what happened to the 12AX7s. And mind you, I haven't fixed that other resistor yet. They're not balanced, but the voltage drop given the resistor here that I had replaced shows it to be on pin 1, 98 volts, pin 6, 83 volts, and that's up from 77 and 61 respectively, with a bias change to 0.78 and 0.87 from 0.5 and 0.6. This thing is floating in normal operating territory, be it low end, but it went from deplorable to acceptable, right? So I want to go and replace that one resistor now is where I'm at, you know, and see if I could balance out that 12AX7 as it specifies for the Gibsonet, and then replace that coupling capacitor between the 12AX7 and the beam power tube and see what we can do. I gotta tell you right now, you can see I'm sitting on the output of the 12AX7 going back into the input of the 12AX7 on the second stage. And I want to show you what the sine wave looks like. And I'm going to adjust the volume on this movie as I do it because it's going to get incredibly loud. I want you to see what the profile looks like. I want you to see how tight that output looks now. I'm going to compare that to the video of what it looked like before, give you an understanding of the improvement we have here. This then begs the question, what does that sine wave look like after coming out of the second stage of the 12AX7, after the coupling capacitor, right before it goes to the grid of the beam power tube? And this is why I'm stopping here and saying, let's hook a guitar to it. So I'm going to show that now. Let's take a look at where I'm clamped in first. So you can see I'm all the way down here, clamped to that coupling capacitor right after it decouples, takes off that DC, right? So this is the AC going into the beam power tube. Again, I'll be adjusting the volume. This is going to get incredibly loud as we crank it full tilt. And there also is noticeable sag when you really take it up to the top. And distortion all the way at the end, you can see that. See that sag bump? That's awesome. Again, I'm going to point out that it is hard to measure distortion there at the top end of the input because I'm using a function generator, as you see, and I'm not using guitar pickup. So I don't have any reference. It could be a much lower voltage than I'm using with the connector that I have in line, my resistor in line that you can't see here because it's down on the floor. So I can't say. So maybe it would be less of a signal and it would stop before it would start distorting and clipping on top. So I'm not going to worry about that right now until I get a guitar on it and I can have a look. When I get a guitar and I could strum it and I could see what the amplitude looks like here, I could then adjust the function generator to match that maximum amplitude that a guitar could get when you beat on it and see what's going on. So I've got the oscilloscope plugged into the first stage just as a reference, and this is before the volume knob. It doesn't matter where the volume sits on the amplifier. I've got it plugged into a guitar, and I'm just trying to get a reference of how much voltage is produced at that first stage when I strum it. So I'm going to strum the guitar right now and get an idea. I've already done this, obviously, so I'm just going to show. And I'm seeing about 12 volts is being produced, and it's sort of a quasi measurement. It's not exact, but 12, 14 volts is produced right there. I'll show it again. So that gives me a good reference to work with. I'm also interested to know the input right after it leaves that jack, what it looks like. So I'm going to measure from a known test point as well. And I've decided to go right off of here. This is right before that resistor coming in on the jack to see what the guitar produces. Right now I have the oscilloscope on the 0.1 scale on that point, and I'm strumming it, and we're seeing that peaking about 0.6 volts maybe coming off of the guitar when I strum it. You see a couple of outliers, but the bulk of it's 0.6 comes down to about 0.3, 0.4 right there. So now we have a baseline. Now armed with this information, I was able to set up the field tech to match the voltage of the guitar to an approximation. I got between 4 and 6. I split the difference. I ended up with 0.5, significantly higher than how I was driving this before. And let me tell you, equally as with the guitar, I was able to drive this to distortion, just like that. I don't know if you can hear it on camera. I could hear it. It's distorting. And what I'm going to do now is I can see, looking at the oscilloscope, that there is clearly no distortion coming into the unit. It stands to reason. We're gonna walk the stages through, and we're gonna see if the distortion is appearing in the 12AX7, and if it's appearing in the beam power tube. We're gonna see what we could do about it. See if we could cut back that bleed off resistor from the beam power tube and see if that could fix it. But definitely way too hot here. Yes, I'll point out that I took the scope out of cal just to get this entirely in the picture. This is the output of the first stage after the coupling capacitor. Not seeing any problems with the input signal. I did not expect to. The 12AX7 should obviously be able to handle a guitar. Given the lower voltage for the plate, however, you know, we still have to check this and make sure there's not an issue. Didn't expect one, didn't find one. Gonna move over to the second stage. I'm gonna look at the volume first to pin 2, make sure that's cool, then we'll move to the second stage. This is gonna get a little bit loud. Believe it or not, I could pull some distortion with the tone knob, but it's not causing the distortion that we're hearing, and I'll show that, and I'm gonna reduce the volume in the actual video. But clearly, it's not coming off the volume knob, so we can move past that. We're going to look at the output of the 12AX7. So I've moved the test probe now. We're after the coupling capacitor that makes its way to the beam power tube, to the grid. And I'll tell you what I'm seeing before I start, because I have to lower the volume when I'm doing it. You see distortion all the way at the end, at the very top when it starts to clip, but I'm hearing it first. It may in fact be the speaker that can't handle it, and if so, we have to adjust that bleed off resistor and just lower the intensity here. But I'll show what's going on here. Before I make it loud, I'm going to show how I turn the tone. Makes it distort a little bit here. When I turn it full tilt, you can see it's almost like a square wave, and that may just be due to the frequency. If I were to change the frequency of the frequency generator, make it another characteristic than that. But I'm going to keep it in the middle here, just leave it alone. But here I go. Now at that point you already heard the distortion, but the wave didn't break up. So I'm going to preemptively lower this oscilloscope so that when the sound breaks up, and I'll put my finger up when it starts to distort, in case it can't be heard in the camera, we'll see if the wave is perfectly fine. See, right there it was already distorting. So what we're hearing is definitely not coming from the waveform there. I have to look at the output of the beam power tube now. Oh, right off the bat, we could see we have a DC problem here on the beam power tube. Look no further. Looking back here, we have the 130 volt plate voltage on pin 7. This sawtooth is something we're going to have to stop and deal with. Yeah, this could be definitely causing an issue. I'm sure this is transposing itself onto the waveform.